Today we're going to begin our next unit on the Pythagorean theorem and radicals. The Pythagorean theorem is an awesome theorem because it's so useful, and you'll see it a lot in different types of applications. So what is this Pythagorean theorem you've been hearing so much about? Well, it says that for any right triangle, the sum of the squares of the legs equals the square of the hypotenuse. There's a lot of words in this, so let's break this down. First of all, the most important thing you see underlined is right, because it only works with right triangles. We can't use it with any type of triangle. The triangle has to be right. Then we see these words called legs and hypotenuse, this funny looking word. The hypotenuse is the longest side of a right triangle. It's always the side across from the right angle. So we call the hypotenuse the longest side, and the two shorter sides are the legs. So here again we have an example of a hypotenuse and the two legs. So what the Pythagorean theorem says is when I square the length of the leg and I square the other length of the leg and add those together, it equals the square of the hypotenuse. So let's look at one example here. We have 3, 4, and 5. Now we have to decide which two are the legs and which one is the hypotenuse. Well, the hypotenuse, first of all, is always going to be the longest side, and it's always going to be across from the right angle. So 5 is our hypotenuse. So that means our two legs are 3 and 4, and so we square both of those. And that's supposed to equal 5 squared. So let's make sure it does. So 3 squared is 9, 4 squared is 16, and 9 and 16 does in fact equal 5 squared, which is 25. And that's our Pythagorean theorem. Now, you would say, but Ms. Dahl, I never see the Pythagorean theorem written leg squared plus leg squared is hypotenuse. I see this funny looking thing, a squared plus b squared equals c squared. Well, where does that come from? Well, they didn't like writing all those words out, so we shortened it and we said a is one of the legs and b is the other leg. Now these are interchangeable. It doesn't matter which one I call a and which one I call b. I can switch it up for each problem and it wouldn't make a difference. C is our hypotenuse, our longest side. So that's where you can see the theorem a squared plus b squared is c squared. This good example shows this squared plus this squared is that squared. So let's try a couple examples. We're going to find the missing side of our right triangle. So we have the sides 6 and 10 and y. In order to use this formula, we have to figure out, well, what is y? Is y a leg or is y the hypotenuse? Well, since the longest side here appears to be this, but remember we can't assume, we have to look at where the right angle is. Well, the right angle is between y and 6, making those the legs, and 10 the hypotenuse. So if we look at our formula, I'm going to call A y, could be b, b 6, and c 10, because our shortest two sides are y and 6, and our longest side is 10. And we're going to plug that into our Pythagorean theorem. So y squared plus 6 squared equals 10 squared. Let's simplify. 6 squared is 36. 10 squared is 100. We're going to cancel our coefficient. We get y squared equals 64. Well, how do we get rid of a square again? We need to square root it. So the square root of y squared means the square root of 64, which we know to be 8. So our length here is 8. Let's look at our second example, and I apologize that the answers have already popped up, so if you're ahead of me, you've already gone through it. But we have 6 and 7 are going to be our legs because they form our right angle, and x is going to be our hypotenuse. So when we put it into the formula, we get 6 squared plus 7 squared is x squared, our unknown. Evaluating, 6 squared is 36, 7 squared is 49, and of course we don't know x squared. Combine those to get 85 is x squared, and the same thing, square root. We're going to square root both sides, and we get x is approximately 9.2. So our hypotenuse is about 9.2 meters in this case. Your turn. I want you to find the missing lengths of these two. Pause the video and give it a shot. Okay, hopefully you figured out that the two legs were 5 and 5, and s was our hypotenuse, our missing value. Putting it into the formula and simplifying, we get s squared is 50. And so when we square root it, S is about 7.1 meters. On the second example, we're going to notice that T is one of the legs. So I called it A. You could have called it B and still gotten the right answer. Putting it into our formula and simplifying, we get T squared is 144. So T is 12. If you're struggling with this, take a minute, pause the video, and work through the examples again, checking your work with my work. If you have questions, bring them to class. Now, there are a couple of things called Pythagorean triples. Really important things to know because they make our life so much easier. There are these special sets of numbers that automatically form a right triangle. The most common one is 3, 4, 5, and you'll see that one a lot. That means if I have a side that's 3 and I have a side that's 4, my hypotenuse is always going to be 5. Or, for example, I have the hypotenuse of 5 and a side of 4, my other leg will always be 3. So these are all triples, all sets, and there are 4 of them that are most common. 3, 4, 5, 5, 12, 13, 7, 24, 25, and 8, 15, 17. And you'll notice in these diagrams, I've shown you all the different triples and kind of how they look. But you'll also notice on one of these that you have 3, 4, 5, and then you see 6, 8, 10. Well, if you notice the relationship, I doubled all these sides. Triples can be doubled or tripled or quadrupled. As long as they're multiples of these numbers, they'll still be a right triangle. So here we have 3, 4, 5, 6, 8, 10, 9, 12, 15, or even multiplying them by a square root. 3 square root of 3, 4 square root of 3, 5 square root of 3. They're all going to come out to be right triangles. So these are just ones that you can memorize to make your life a little bit easier. Last thing. We're always asking, when are we ever going to use this? Or what is an application of this problem? So here's one example. Amy's best friend lives across Green Lake. And to drive around the lake, Amy must drive 15 miles directly south and then 12 miles directly east. If Amy decides to use a boat to cut her journey across the lake, how many miles will she take off her journey? So let's look. Here's our beautiful Green Lake. Amy's going to drive 15 miles from this point south. Then she's going to drive directly east 12 miles. Now this should start kind of looking like a right angle. And I want to know how much longer is that than if she goes straight across the lake, which we're going to call x because we don't know how long that is. It doesn't tell us. Now if we push these together, we have a beautiful right triangle with sides 15, 12, and x. Using our Pythagorean theorem, we know 15 and 12 are the legs, and we know x is the hypotenuse. We can simplify and solve, getting x is about 19.2 miles, direct miles across the lake. So the question asks now, how much will it take off her journey? So we've got to look at her original journey was 15 plus 12, or 27 miles. If she goes by boat, it's only 19.2 miles. So she's going to save 7.8 miles. I think that's a pretty good deal for her cutting across the lake. And that's the end of our video. Bring your questions to class. Have a good night.